हेलो बच्चों, आज एक नए अंदाज के साथ एक नया चैप्टर स्टार्ट करने जा रहा हूँ, दैट इज़ इलेक्ट्रिसिटी। आए दिन हम लोग इलेक्ट्रिसिटी के बारे में पढ़ते हैं, इवन सुनते भी हैं, बट इसके बारे में आप लोग को आज ब्रीफ नॉलेज देने जा रहा हूँ। तो बच्चों, चलो स्टार्ट करते हैं आज का नया चैप्टर, इलेक्ट्रिसिटी। Electricity. First of all, electricity is classified into two groups. First is the static, and second is the current electricity. First is the static electricity, and second one is the current electricity. Current electricity. What is the meaning of this static electricity and current electricity? Static electricity मेरे बच्चों, इसमें charges rest में होते हैं. So basically, static electricity means when the charges are at rest. Charges are at rest. And this current electricity means when the charges are in motion. Charges are in motions. तो बेसिकली हम लोग करंट इलेक्ट्रिसिटी के बारे में पढ़ने जा रहे हैं कि व्हाट इज करंट इलेक्ट्रिसिटी, व्हाट आर द इंपॉर्टेंट टॉपिक्स ऑफ दिस करंट इलेक्ट्रिसिटी। तो बच्चों, आज स्टार्ट करते हैं ये टॉपिक करंट इलेक्ट्रिसिटी क्या है। सबसे पहले करंट इलेक्ट्रिसिटी जानने के पहले करंट इलेक्ट्रिसिटी होता क्या है, वो किस चीज से जुड़ा हुआ है, किस चीज से बनता है। तो फर्स्ट ऑफ ऑल वी हैव टू टैकल द पॉइंट दैट इज नोन एज चार्ज। चार्ज प्लेज अ वेरी इंपॉर्टेंट रोल इन द प्रोडक्शन ऑफ करंट इलेक्ट्रिसिटी। तो बच्चों आओ स्टार्ट करते हैं चार्जेस से। व्हाट इज द मीन ऑफ चार्ज? Charge. Charge. It is the tendency of the subatomic particles such as proton, electron and neutron. Once again I am saying my dear, बच्चों हमेशा याद रखोगे चार्ज क्या होते हैं। चार्ज सबएटॉमिक पार्टिकल जैसे इलेक्ट्रॉन, प्रोटॉन और न्यूट्रॉन का टेंडेंसी, इनहेरेंट क्वालिटीज होते हैं। So ultimately we can say that this is the properties of the subatomic particles such as electron, proton and neutron. It is denoted by small q. It is denoted by small q. चार्ज जो होते हैं वो small q से डिनोट किए जाते हैं। Now SI unit of charge q is Coulomb. Is Coulomb, which is denoted by capital C. एक्चुअली बच्चों आप लोग को ये भी जानना जरूरी है कि ये कूलम का जो कंसेप्ट है वो आया कहां से है। ये कूलम का कंसेप्ट, सर कूलम हैज गिवन द एंटायर कंसेप्ट ऑफ इलेक्ट्रोस्टैटिक। ही टोल्ड दैट इफ 2 point charges is kept apart from each other at a certain distance r, then a certain force of attractions will exerted in between 2 point charges. These point charges should directly proportional to the product of the two charges, that is q1 and q2, and the same force of attractions is inversely proportional to the square of the distance in between two charges. तो बच्चों आओ इसके बारे में हम लोग ब्रीफली जानते हैं कि सर कूलम ने क्या बताया था चार्ज के बारे में। This entire law is known as Coulomb's law. Coulomb's law. According to Coulomb's law, he has taken the 2-point charges. Suppose this one is the point charges Q1, this one is the point charges Q2. These 2-point charges are kept apart from a certain distance r. Certain distance r. So, according to Coulomb's law, he told that a certain force of attractions can be exerted in between these 2-point charges. In between these 2-point charges. That is, that force of attractions is directly proportional to the product of the 2-point charges Q1 and Q2. So suppose F is the force of attractions exerted by the 2-point charges. This F is directly proportional to the product of the 2-point charges. And the same force of attractions is inversely proportional to the square of the distance between 2-point charges. That is, F is inversely proportional to the square between these 2-point charges. Now assume this one is the first equations. First. This one is the second equations. This one is the second equation. When we combine this equation first and second, we get that F proportional to Q1, Q2 upon R square. Now, after that, we have to remove this proportional sign. हम लोग को अब क्या करना है? इस proportional sign को हटाना है. तो जब भी हम लोग इस proportional sign को हटाते हैं, एक constant term आते हैं. Suppose if we are going to remove this proportional term, so F equals to K Q1 Q2 upon R square, where K is known as constant of proportionality. But इसके अलावा भी सर कूलम्स ने इस कांस्टेंट ऑफ प्रोपोर्शनलिटी के बारे में कुछ और भी बोले हैं. He told that this constant of proportionality is being equals to 1 by 4 pi epsilon naught into Q1 Q2 upon R square. Now this is the entire equations of this force of attractions which is exerted in between the 2-point charges. Now the value of 1 by 4 pi epsilon naught is also known as absolute value of permittivity in free space or vacuum. Now it retains its own values also. इसका एक अपना values भी होता है. This 1 by 4 pi epsilon naught is being equals to 9 into 10 to the power 9, and there is a certain unit. Now बच्चों, इसमें क्या यूनिट लगेगा? इस यूनिट को निकालने सीखते हैं. इसको कैसे निकाला जाता है या क्या यूनिट लगेगा, ये यूनिट को निकालते हैं. Now here we demonstrated that F equals to K into Q1 Q2 upon R square. So can you say my dear, K is B equals to F R square upon Q1 dot Q2. Now अब क्या करेंगे बच्चों? अब हम लोग सारे टर्म्स के SI यूनिट को निकालते हैं. The SI unit of force is Newton, SI unit of radius or distance is meter square, and the SI unit of charge is Coulomb. So Coulomb into Coulomb, Coulomb square. It will be Coulomb square. So ultimately we can say that its unit is Newton meter square per Coulomb square. So here the unit will be Newton meter square per Coulomb square. This entire thing has demonstrated by Sir Coulomb, and he is invented this charge, and the actual, this is the actual value of this 1 by 4 pi epsilon naught. This is constant, fixed. It's never be changeable. After that, we have to discuss about the types of charges. There are two types of charges. There are two types of charges. First, the next heading is types of charges. Next heading is types of charges. There are two types of charges. First is the positive charge. Second is negative charge. Now, remember one thing, मेरे बच्चों. Positive charge. What is the meaning of positive charge? Proton carries the positive charge carrier. Proton carries the positive charge carrier. It is denoted by small p. Denoted by small p. Proton is denoted by small p, and the value of one proton is equals to plus 1.6 into 10 to the power minus 19 Coulomb, because Coulomb is the SI unit of charge. Okay. Now, negative charge. Electron carries negative charges. Electron carries negative charges. It is denoted by small e, and the value of one electron equals to minus 1.6 into 10 to the power minus 19 Coulomb. So ultimately we are getting that हम लोग क्या मिल रहा है बच्चों यहाँ से, positive and negative charge both are same in magnitude, means their numerical values are same but opposed in nature. Their sign are different. Proton carry positive charge, electron carry negative charge. Okay, now after that we had discussed about the charge. Charge is denoted by small q. अब मेरे प्यारे बच्चों, चार्ज का एक और बड़ा भाई होता है, that is known as quantization of charge, that is denoted by capital Q. So the next topic is quantization of charge. Next topic is quantization of charge. Quantization of charge. This quantization of charge is denoted by capital Q. It is denoted by capital Q, and it is the integral multiple of charges due to the presence of electrons or protons. So ultimately we can say that what? Once again I am repeating the definitions of quantization of charge, that is, it is the integral multiple of charges. Or simply you can say that quantization of charge is defined as the integral multiple of charges due to the presence of electrons or protons. It is denoted by Q. So Q equals to plus minus Ne. This is the base equations. Now when we chalk out the electron and proton, if suppose the charges, this quantization of charge is due to the cause of electron, so we can write Q equals to minus Ne. And suppose if in the place of electron, suppose electron is absent, if the charge can be happened, so quantization of charge due to proton, that should be B equals to Q equals to plus Np. This is the two equations when we divide these main equations. These two equations can be chalked out. बच्चों ये main equations है. This is the equation of quantization of charge. But इसको हम लोग दो पार्ट में तोड़ सकते हैं इलेक्ट्रॉन और प्रोटॉन के कंसेप्ट के हिसाब से. एक न्यूमेरिकल्स इसमें बनता है. अगर आपसे कोई पूछ लिया कि सपोज दिस इज अ कंडक्टर, which suppose this is a conductor carrying 1 coulomb of charge, carrying 1 coulomb of charge, then what will be the number of electrons present in this conductor? So here charge is given 1 coulomb, that is capital Q equals to what, 1 coulomb, and as they are asking number of free electrons present in this conductor, so that means we ultimately are going to find the value of n. If we are going to find value of n, this n indicates the number of electrons, so we have to tackle or we have to use the value of one magnitude of electron, that is 1e equals to minus 1.6 into 10 to the power minus 19 coulomb. According to quantization of charge, Q equals to minus n e, then n equals to minus q upon e. Now we can write over here 1. It's a 1 magnitude of electron. 1 magnitude of electron. Now the value of q, charge 1, and the value of 1 electron is minus 1.6 into 10 to the power minus 19. Minus 19. Now this minus cancel out. Remove this dot. Here should be 10. Both are 1 by 2. 2 5 ja, 2 8 ja. So ultimately we got 5 by 8. So 5 by 8 means 0.625. It's a 0.625 into this 10 to the power minus 19 should be go up. It really becomes into 10 to the power plus 19. बट बच्चों फिजिक्स के न्यूमेरिकल में एक बात हमेशा याद रखना है कि जो भी वैल्यूज यहाँ आए उस वैल्यू को स्टैंडर्ड फॉर्म में लिखना है। स्टैंडर्ड फॉर्म होता क्या है? डेसिमल को हमेशा एक नंबर के बाद पुट करना है, मींस पॉइंट के पहले एक डिजिट होना जरूरी है। सो हियर विल बी दिस डॉट शुड बी रिप्लेस्ड ओवर हियर, इट विल बी 6.25 वन टाइम्स इट जंप्ड, सो here will be 10 to the power 19 minus 1, power 1 घट जाएगा, it will be 10 to the power 18. This much electron is present in 1 coulomb of charge. If a conductor is carrying 1 coulomb of charge, अगर एक कंडक्टर के अंदर 1 coulomb चार्ज फ्लो हो रहा है तो उसमें 6.25 into 10 to the power 18 number of electrons are present. Think my dear, बच्चों सोचो, अगर इसमें हम एक की जगह में अगर 2, 4, 10 चार जगह ले लें तो कितने नंबर ऑफ इलेक्ट्रॉन्स एक कंडक्टर में पाए जाएंगे? ओके, दिस इज द न्यूमेरिकल, इट्स अ वेरी इंपॉर्टेंट न्यूमेरिकल। सीएससी में ये न्यूमेरिकल्स हमेशा पूछा जाता है, चाहे वो 2 मार्क्स के लिए हो चाहे 1 मार्क्स के लिए हो। क्लियर? नाउ द नेक्स्ट टॉपिक इज द प्रॉपर्टीज ऑफ चार्ज। प्रॉपर्टीज ऑफ चार्ज। तो बच्चों अब हम लोग जानेंगे प्रॉपर्टीज ऑफ चार्ज क्या होता है, चार्ज के अंदर क्या प्रॉपर्टीज होते हैं कि चार्ज को यूनिक बना दिया जाता है, चार्ज के अंदर वो एक क्या प्रॉपर्टीज होते हैं कि चार्ज अपने में ही यूनिक होते हैं। यस, तो बच्चों अभी हम लोग डिस्कस करने जा रहे हैं चार्जेस की प्रॉपर्टीज के बारे में, चार्ज का प्रॉपर्टीज क्या होते हैं। द नेक्स्ट टॉपिक इज properties of charge. Properties of charge. The first properties, like charges repel each other, unlike charges attract each other. That means it shows attractive as well as repulsive properties. The first property is known as attractive and repulsive property. Properties of charges. Properties of charges, that means like charges same charge अपने में रिपेल हो जाते हैं, अनलाइक चार्जेस अट्रैक्ट होते हैं। यानी प्लस प्लस रिपेल, माइनस माइनस रिपेल, बट प्लस माइनस attract, minus plus attract. Next properties. Charges are conservative in nature, means charge can neither be created nor destroyed. So next is charges are conservative in nature. Third, charges are quantized. Right now we have discussed about the quantization of charges. So charges are quantized in nature. Charges are quantized in nature. Next properties. Charges. These three charges. First properties of charge I told: attractive and repulsive property of charges. Second, charges are quantized in nature, and after that charges are conservative in nature. Next, it's a very important properties of charge, that is additive nature of charges. The fourth properties of charge, that is known as additive nature of charges. Charges are additive in nature. Charges are additive in nature. It means that suppose this is a point charge in which so many charges are coming to join over here. These are the charges, they are entering to this point, and these two are releasing. If it is Q1 charge, if it is Q2, this one is Q3, this one is Q4, this one is Q5. Ultimately, the net charge on this point is known as Q net equals to Q1 plus Q2 plus Q3 plus, but as charge 4 and charge 5 are going outward, so they are taken negative. बच्चों हमेशा याद रखोगे, जो चार्जेस अंदर आता है उस चार्जेस को हम लोग प्लस में लेते हैं, और जो चार्जेस बाहर जाता है away from that point, that should be taken always negative. So it will be plus, but in a bracket we have to write minus Q4, and then again plus, in bracket we will write Q5. So this is the additive nature of charges. तो बच्चों ये चार्ज के प्रॉपर्टीज हो गए.